my recording. As y'all are finishing writing these problems down, make sure you see that it continues from the video that I had to post yesterday. Apologize for that last minute notice. It's just, I needed to stay home. So make sure you see though, our video from yesterday focused on intercepts, right? It's still talking about functions. For each input, there's one output. We're now going to focus on polynomial functions for a little while, okay? So like how we talked about linears, where we said, hey, what is the slope? What is the y-intercept? What is point slope form? What is the slope formula, right? Those are some of the things that we want to make sure we keep in mind when we deal with linears. Quadratics is another group that we can spend some time on because it has some special characteristics we can use. For one, as we saw, I gave us, 4 different problems on the video, and we were able to solve all of them, right? We can get the solutions for quadratics at all times. Now, with that said, make sure you go back to the last one. I reviewed completing the square, something we need to know, but when did I say we have to know how to complete the square? What assessment did I say was going to be on it? You need to know how to complete the square. The final, right? That's when we need it, right? For this test, I could put a problem where you could complete the square, but there are alternatives. However, for the final, when we talk about circles, completing square is what's needed. So please keep that in mind. With that said, though, the quadratic formula is the alternative. I made sure to show both of those in the video, though. So if you need a review of those things and you haven't seen the video, make sure you do that because I also had an assignment attached to that. And I only had like 10 people do the assignment. I think it was. I think we have 12 people here. So that means at least 2 people in the room didn't do it. Okay, so you need to watch the video as you take your notes, which hopefully you're doing anyways, right? Scan that and upload it. I'll allow y'all do that. I don't think I put a due date on it. Well, you could probably still submit it and it'll just be marked late. So if you haven't done it yet, make sure you do it, okay? I'll probably count that in as a bonus grade, either in the attendance or the homework assignments, depending on where it best fits for everybody, okay? Kennedy, right? Now, with everything in place now, what we want to do is look at this from the function perspective, not just be able to find points, but the overall pattern of the function. Now, keep in mind, we already know what this graph looks like. So as we go deal with this, make sure you remind yourselves that we're dealing with the parent function x squared. And if we go in and draw that graph real quick, we're looking at something that looks like such. All right. So when we talk about quadratics, these are the things that we have in mind. So yesterday we reviewed on how to factor, complete the square, and solve using quadratic formula. Right now we're going to bring this together with the full function as far as graphing is concerned. Okay, now for review then, let's start with finding these intercepts. So what's the first intercept we could find? Y-intercept. Now, do you have to do the y-intercept first? No, right? I just feel that's a great place to start just because you could be like, hey, h of 0 equals what? You could write it all out, right? But 3 times 0 is 0. 2 times 0 is 0. So it's going to be just -8. Now, can I do the same thing with J, though? No, because to understand that's going to be what we call standard or vertex form. So one thing that I would say is make sure you look at this as standard / vertex form. I think the Pearson side uses vertex form, which I'm fine with that, okay? And we're going to talk about that a little bit more with the graph. That's what we're going to connect to, because as you saw from that second part, I want us to identify the minimum or maximum value and where it occurs. And that'll be something we see there, okay? But make sure you see with this one, we do need to go through that process of using the order of operations. Be careful, okay? But going over here with h of x, the terms with the x are gone because they're zeros. That's why we look straight to the constant, okay? Now, what did someone find out, though, when they went to the x-intercepts? Or what we're going to call the zeros of the function? Had anybody got that far yet? What were you able to do? So it worked. Yeah, so everyone found they were able to factor. I like the T chart, right? Table, whatever chart, table, doesn't matter. Sorry. That's, to me, like I said, that's just a way for me to write it down and show you all that, hey, it doesn't have to be in your head the whole time, right? Get it out on a piece of paper. Just be careful again. Hopefully one of the things that you saw here, 8 times C is negative 24. We don't want to do just the negative 8. We need 3 times the negative 8. Okay. And then our B value is negative 2. All right. And what factors did you end up using? Do we all agree with that? And the other wonderful thing that I like about this is if you do get stuck, you could just go through your list. Now, 24 has a few more than some of the other numbers out there as far as factors, but that's not unreasonable. In fact, as you saw, I just went 1, 2, 3, 4. You could try 5, but it won't work. Right? And then you already have the 6 listed, so you have all your factors. Okay. Now, the way I showed it before, I'm going to go through this a little bit quicker now since we have practiced it. The factoring by grouping was the approach that I've used in the past. If that's what you're comfortable with, make sure you're practicing it so that you have your confidence as well. But what we find here is we do indeed get 2 factors. Any concerns with where these factors are coming from? What do we do with the factors in? Right? Anything that equals 0, we have multiplication, right? We could take each of those pieces, each individual factor, and say it must equal 0. Now, keep in mind, right now we're dealing with the quadratic, but it could be cubic like we saw in the first test, right? So as we go into polynomials right now, we're focused on 2 solutions, but we could add more depending on that exponent. So keep that in mind as well. All right, so there's my 2 solutions. Why is it a negative on the 4/3 though? Yeah, you have to subtract the 4. Now, if you do that on the test, you think I'm going to make a big deal at this point? Not at all. I think we're at a place where we can say, hey, this is something I could follow to see where you're coming from. Is that clear to everyone? I think we've practiced it enough that if you skip, put everything into one step there, I'm fine with that.
Oh, okay. Okay.
Yeah, all I did was skip the whole 3x equals negative 4 part, right? But since it's equal to 0, we could see where the 4 comes. We could see where the 3 comes. The key was why is it negative, right? Because we have to subtract it from both sides. Does everyone follow that? Any concerns with this, with h of x and finding those intercepts? Okay. Now, why is it you only have one y-intercept? Huh? But why is there only one of them? What are we working with that would guarantee when I plug in 0, I'm only getting one thing back? It's quadratic, yes, but it's a function. Remember, we're working with functions, so I only have one y-intercept. However, remember down here, I can have multiple x-intercepts though. We can conclude from this work that, hey, this function's not 1-to-1, right? I think that would be enough evidence to show that this would fail the horizontal line test. Does everyone see that? But make sure you keep that in mind that when I talk about x-intercepts, yeah, I can have more than one. That's okay. It's the y-intercept that we only want one of them, okay? Any concerns though before I go over here and finish up with Jay? So in agreement with -9? Any concerns there? Now that one definitely had a little bit more work from the the y-intercept side, but what I hope we see is that when we deal with that x-intercepts, we don't have to do the guess and check aspect. Oops. Now, as I was talking with someone up before class, as you see this problem here, we have to go back to test 1. We only have one x, right? So the best approach to solving this is going to focus on what's around the x. The parentheses. Why are the parentheses there? Because it's squared, right? What can get rid of a square? Yeah, that's where the square root comes in. So what we want to do here is add the 12 to both sides. and then divide by 3. All right. We're trying to take the most direct approach to solving this right now. So when we get here, right, we divided by 3. We've got x plus 1 squared from by itself. We can now introduce the square root. And we like the square root because on the left side, I can put x minus 1. But what do I have to put to make sure I do this correctly? Plus or minus. So it has to be plus or minus the square root of 4, which is 2. Now make sure you remember here, that means I now have 2 solutions. Not just 1, but 2. Any concerns so far? All right. So the next step then would be like, hey, x equals positive 1 because I have to add it to both sides, plus or minus 2, right? But make sure you see here, you want to break that down to the 2 solutions because what is 1 plus 2? Right? And then 1 minus 2 is negative 1. Now make sure you make a note to yourself, like what we did here was 1 plus 2. No, here is 1 minus 2. But that goes back to, remember on the first test where I said, hey, we are going to have a problem just like this one. I think that one might have complex solutions, if I remember right. Which means prepare for I, as we saw on the video yesterday. And those just coming in, make sure you're going in and doing the video, watching it, and completing the assignment like I had asked. Any questions so I can clear for JLX? Help someone feel better about it? All right, so before I move forward, though, I want to make sure to go over a couple situations as far as factoring is concerned. All right. I hadn't really done a lot of these, but we always want to make sure to watch out for this. Okay, so write these down. I'm going to do again. These are going to be a little bit quicker, but there was a couple things I want to make sure add that I didn't do yesterday. As you're finishing up writing down that first one, though, make sure you look at it, and as you're looking at it, identify something that stands out to you. So what stands out to someone with this first one? Huh? All right. All right. How many terms do we have? 3. So the quadratic trinomial. All right. X squared, right? So it's quadratic trinomial. What are we trying to do if I say factor completely? Well, we're not solving right now. We're just factoring.
I'll give coefficient of 1.
I was gonna say get X on one side.
One side of what? There's no equal sign. We're just factoring. We don't want to mix up our skills, right? We're not trying to mix up skills right now. Right? So we can identify A, B, and C. But before we do that, what's going on with A, B, and C? What do you notice about A, B, and C?
Are they all multiple of 3?
They're all multiple of 3s. It's very important that you recognize that first because that's going to help make the problem easier to work with. Right? If we build our chart up here with this first one, we're going to be dealing with negative 27. But once I get down here, that now turns into negative 3, which is a lot nicer to work with, right? Because when you look at negative 3 and you consider the fact that that middle value is negative 2, all of a sudden the only factors to work with are 1 and 3. Right? And we'll be like, hey, negative 3 times 1 and negative 3 plus 1. And you'll find that, hey, that made the factoring a little bit easier to work with. Now, if you need to, fill in with the grouping aspect, but the coefficients have been 1, so we see the factors reflect the numbers that we just said to use. Now, could you still have used the negative 27 and got it done? Yeah, of course, right? However, what did I do with the second one here that we want to make sure to watch out for? I'm talking about over here, this one.
Oh.
Yeah, this one is multiplication. We're good here now. What's going on here? There's cube now, right? But what's going on with each of the terms?
They all have four legs,
They all have 4 in common, but they also all have what? An X, right? So we can pull this out, and this is where we have to use a greatest common factor. We need to get the X out, right? So make sure you always check for a greatest common factor first. All right, you remember yesterday I did one of them. Let me see, was it here? Oh, no, wrong class, sorry. I did this one where we had the greatest common factor, right? So this might be a situation like, okay, yeah, it's only 2 terms. It's not difference of squares, so let's try greatest common factor. But make sure you see here, we definitely need to take out that greatest common factor because each term has X on it. Now, again, make sure you take the 4 with it as well, because that's going to make everything easier to work with. We'll have X squared minus 3X plus 2. Right? And what factors of 2 give us 3? Right. So again, just 2 and 1 wasn't much to choose from, but the key was I had to do the GCF first. Does everyone see that? Now here we need to do the GCF with the second one though, because of the variable. The first one, we didn't necessarily need to do the GCF. That wouldn't keep us from solving, but it made it easier to work with. Getting the 3 out made it easier to work with from the factoring perspective. The same way the second one, by pulling out the 4 with the X, I get something that's more reasonable to work with. Okay. Any questions with that? Now make sure, like, as far as notes to yourself here with these two, is just kind of watching out for the GCFs. That's my main thing. We're focused on quadratics right now, but we're definitely going to be jumping into other types of polynomials as well. Okay. Anything I clear up though before we move to the graphing side? All right, so the next part is I wanted to graph a couple functions. Now make sure you see that both the functions I asked us to graph are in that what I just called standard/vertex form. All right, the reason we like this is because what we saw for test 2 is that this allows us to graph using transformations. Only one X is involved here, right? Now I could multiply it out, right? We could simplify this. We would have an X squared term, an X term, but in this form here, I can identify transformations to graph. Okay. Now keep in mind, we're still working with that U shape, what we call a parabola. All right. So when I go through this process, we would say, hey, like I have a horizontal transformation here, where I'm going to shift right 3. But then I have a vertical transformation where I'm going to stretch the graph by a factor of 2. All right. What point am I going to plot first, though? All right, so where does that go? Well, what point is that? 3, 0. Positive 3, comma 0, right? There was no shift up or down, so it stays there. But this was an important point, right? Because remember when we talked about the parent function, this is where my U is going to come down and meet. Now, did I have a reflection for this graph? No, so my graph still needs to go up. Right now, just be careful here. Get your points as needed, because when I go to graph this is going to be stretched by a factor of 2. So my graph is definitely going to look a little bit more narrow than the parent function itself. Stretch is narrow. Always grab that rubber band if you have to. Remember, hey, it's going to get closer together when I pull it apart. Now, for me, hopefully you saw I just focused on these points here. I went up 2 rather than up 1. Now, the table, though, is helpful. If you get stuck, build a table. That was one of the things that we talked about with transformations. Start with that 3, 0, and then use points around that. That will get you what you need. It just takes more time when you use a table rather than get comfortable with, hey, what does this do to each individual point? Okay. Now, what you're going to find here, though, is we want to start identifying things in more detail, right? Now, we've talked about minimum and maximum values on the previous test, but that was more of a homework assignment. I don't necessarily do it on the test, though, because sometimes we can't really guarantee we know the value. However, with a quadratic, we have confidence that we know this value. So what is the minimum or maximum value of this graph?
The middle one would be the three. I mean, the zero.
Which one is it?
Um,
So you're highlighting this point though, right? Does everyone agree with that? That's the point we're highlighting here? We're saying it's a minimum though, because it's at the bottom of the graph. So make sure you see that this is what we're calling a minimum, right? Technically, we call it a local minimum. In this particular graph, you might see the word absolute minimum. But the minimum value is 0. Okay. The minimum value itself is 0. Now, what x value does that occur at? X is 3. So we have to understand that when we ask for the minimum value, we want the y value, but it occurs at x equal to 3. Now, for quadratics, we give this a special name, right? So as you see here, I have this name called the vertex, right? The vertex will always be h comma k, and this is only good for quadratics. Vertex is only for quadratics. But you'll see here that that ordered pair highlights the minimum or maximum value that we're talking about, and then where it occurs at. But as we've talked about, that's our horizontal and vertical shifts, right? That's where we're getting at, and I totally wrote it backwards. Sorry, y'all. Yes. That doesn't look like a K? That's better. Now, if I write my ordered pair correctly, right? H comma K is going to represent our vertex, which means what does H equal? Which is our X value, right? And then K equals our Y value, which would be 0. Okay. Huh? Yeah, no, that's going to be something new. Yeah, we're moving because what we're saying is we're going to focus on this for a specific purpose now. And a vertex is a special point because it's the turning point of our graph, right? It goes from decreasing on one side to all of a sudden now it's increasing on the other side, right? It also represents the minimum value of this graph, right? So there's different things we can key onto. So finding the vertex is very important. Now this is nice, right? Hopefully you catch on to it. When I have something in standard, what I call vertex form, we can kind of see the vertex based on shifts. Everyone see that? There's no vertical shift, hence the 0. This says to go right 3, hence the +3. So what we're going to see here moving forward, when we look at quadratics, we can actually write them in the form f of x equals a times x minus h squared plus k. Hopefully what you'll see there is a would be then our stretch or shrink. And it's the same a that we see if we multiply this out. Those will be similar statements, but they're different forms. If you remember, we had slope-intercept form for linears. The homework made you use the standard and general form as well sometimes, okay? Now, what you'll see here, though, the big difference is when it's in that vertex form, we have the horizontal and vertical shift, which is where we're going to use to point to what we're calling the vertex now, okay? What's the domain of all quadratics? All real numbers, right? But this is the next thing the vertex helps me. Once I identify the vertex and whether it's a min or max, I now have the range. Because we know it's a minimum value, we would say 0 to infinity. This is where, again, our K value is used. Why is it on the left, though, rather than on the right?
Because that's what we found. That's where the minimum is.
Right, that's the minimum. I'm going up from there, right? So we're going up from here, so we need to make sure we reflect that. Questions? Now, is everything going to be in this nice form for us to graph with? By no means, hence why I made sure to, again, to show you completing the square yesterday, right? We need to understand where this comes from. So we're going to practice the completing square again here in a second. But as far as graphing is concerned, make sure you saw the first two I want to do were already in this form, okay? Is there anything I could clear up for someone though before we look at the second? All right, what made this one fun? Huh?
already know.
Right? So what can we go identify right away? Our H and K, right? Which is the, well, the A, we can say A is negative 1/2. Yes, I agree with that. But make sure you see, as you're saying, H and K is negative 4,5. I know my vertex right now. Is that vertex a minimum or maximum value before I even graph it? So when I go plot negative 4, 5, where's my graph going from there? It's going down. So if this graph is going down, is that a minimum or maximum value? It's a maximum value. So now we're going to show a maximum value of what?
Um,
5, right? That's where our K value gets brought in, right? What does the negative 4 tell us though? Where it occurs at. Here's the key. That will tell us where this occurs at. Hopefully you see here again, we're pointing at the horizontal and vertical shift. This is only true for quadratics now, right? Now, what graph is similar to the U-shape that does have something we can sometimes use? Absolute value, but we won't call it a vertex though, okay? Absolute value makes that V shape. So if you ever had to take a calculus course, you would say how big of a difference that V is to the smooth turn of the U, right? There's a difference from higher levels of math. So for us, I say there is similarities, but be careful moving forward. Is that clear to everyone? Now, hopefully what you're seeing, I'm not necessarily doing anything new today. All I'm trying to bring in is new terms, right? The vertex. Now, what did I make fun about graphing this one? What did I make us use? The 1/2, right? The key there is to remember, is that a stretch or a shrink? Right? So we have the negative, which is a reflection, right? And then we have a shrink by a factor of 1/2. Okay, but again, if you get stuck on these things, go make your table. The first point that we should be focusing on is negative 4, 5, and then just plug in things around that. Go plug in and get your points. All right. The nice thing about that, though, if you remember 2 squared is 4, instead of going down 4, how far did I go down here? And why is 2 significant with a,
That's all the time.
it's half of 4, right? 2 is half of 4. We don't need opposite reciprocals right now. No, it just happened, like I said, technically 2 squared is 4, right? So that'd be a nice point to key into. Whereas remember over here, I keyed into the first point on either side, right? But instead of going up 1, how far did I go up? 2, because that was my stretch. Now, if as you practice that and you can get confident with that, if not, build your table. There's no excuse not to do that. You have to be able to identify the shifts. There's nothing that I can say that will get you away from being able to identify the shifts. You have to be able to do that. So if you don't see the significance of negative 4 and 5, that's where we need to go back in our notes and go back through those things that we looked at as far as graphing transformations. If you notice, when I graph doing transformations, even the one on the test, I focused more on shifts and reflections than anything. So the good thing I did here for you was give a quick review of stretch and shrink, and we'll do more as we move forward, okay? Any concern though with where we're getting the max of 5 that occurs at negative 4? What's our domain? So did that change at all? Oops, quadratic, right? What changed though with this one versus the other one? All right, so there's a reversal of the order here, right? The 5 is going to be the end of this interval because that's the highest I can go, right? So we have to make sure to see the difference here when we look at when we have a max versus whenever we have a minimum value, right? Make sure you compare and contrast those intervals. Because that's going to be helpful to kind of remind yourself, hey, if it's a max, I can use any number below it. What are we putting on the 5, though? That is important. A bracket, because remember, 5 is one of the points I worked with, right? So make sure you remember that as well. Also know as you finish writing this down, I could ask for increasing and decreasing, right? So know that like, hey, from negative infinity to -4, this one's increasing. From -4 to infinity, it's decreasing. And the key is looking at this movement of going up versus going down. Okay. Is there anything I can help someone feel better about graphing with? So what's the special name I use to discuss the horizontal and vertical shift of quadratics? The vertex, right? That's the key. All the vertex is me calculating what's my horizontal vertical shift. Now we like the vertex though, because that keys on exactly where the graph is turning. That's the whole thing we love about the vertex. We know exactly where it's turning now. Okay. Now, with that said though, what in the world do I do if I give it to you in this form here? Right? What if I give you a function that's in what we call the general form rather than that vertex or standard form? Okay. Does that mean it doesn't have a vertex? No, I just got to do the work to find it, right? Is the key. Now, if we have time, today, I'll make sure to show you the formula. But what you're going to find is when I do that process, we've already seen it, so it's not going to be new. But what I want to do here is to show you that this goes back to completing the square, right? Because remember, how do I rewrite this if I wanted to simplify it? Write it twice though, right? Where, hey, I could simplify that if I wanted to, but we liked it in that form because I could identify the shifts, right? I could identify transformations. So here, our objective in completing the square is to get it in a place where I can go get the graph a little bit easier. Now, keep in mind, we like this one because like the y-intercept is 3 and -17, right? So there's benefits to both forms. If I ask you to factor them, this one's a little bit nicer as far as starting that process. Now, neither of these are factorable though. But if we had to, a trinomial, we got steps we could follow, okay? However, again, since these aren't nice ones to factor, this is where completing the square definitely will help us, okay? Now, what you're going to find is, why am I circling these first as far as completing the square? That's our focus, right? We have x squared. Now, what did we say the coefficient should be for completing the square to work smoothly? 1, right? So here, a is equal to 1 already, but this one, we're going to have to do some work, right? So moving forward, we have to do something. Okay. Now, what you're going to find is we're not solving an equation right now, but we still can complete the square. So make sure to keep that in mind. What we're going to find here is I'm going to use some brackets and I'm going to say x squared minus 6x bracket and then the plus 3. What am I trying to isolate by putting those brackets? That, but what's our focus though? What did I put the brackets around?
X's?
The x's, right? Does everyone see that? The plus 3 we isolated. Yes, I agree with that. Hey, I don't need this right now. I'll deal with that later. The variable terms, yeah, those are variable terms, yes. We did isolate the 3 though. I'm not disagreeing with that, but our focus though is going to be, hey, let's get these variable terms by themselves. A is already 1. So what's the only number we're focused on with the focus that we have? -6. What do I need to do with the -6 though to complete the square? Not just square it. Take half of b and then square it. Now think about this. You could kind of see already that this is going to be x minus 3, x minus 3. That's why we're breaking it in half. That's going to be our factors. Okay. But we can't just do that because if we multiply this out, how many terms is it going to give me? That gives me 3 terms, right? What term am I missing right now? Well, the 3, yeah, we'll bring the 3 back in. That's why I kept the brackets there, okay? I did keep the brackets for that purpose, but make sure you see we didn't have a 9 at all. Well, what's half of -6? Right? And then what's -3 squared? So doesn't that give me what we're looking for? Now, the key to remember here is when I do this, I'm putting something that wasn't there before. Is that clear to everyone? So when I do that, I need to make sure to acknowledge that. For an equation, we would just say, hey, add 9 to both sides, right? Using the addition property equalities. What number can I add to this, though, to make sure I really didn't change it at all? I don't have two sides, though. Right? So what number could we add to an expression that doesn't change the expression? So is 2 plus 1 the same as 2? No. We could add 0. Now, we don't want 0 here. We want 9, right? What could we put, though, to say, well, really, we're putting 0. We just wrote it different. If we need to put plus 9, what could we put right behind it that says this is really 0? If I give 9, right, what would I have to do immediately for it to be 0? I wish I had some money. If I give you $9, what would I have to do for you to have $0? Take it right back, right? Well, guess what? That's the same thing we do here.
Oh, no, I understand what he was putting down.
No, that's why I was trying to find a way to state it. That's why with the money thing, if I gave you $9, I'd have to take it right back for you to be back at 0, right? So that's what we're doing here. Understand the purpose of this is, hey, I need the 9 for factoring purposes, right? As you see here, I multiplied it out just to make sure to show you we broke the -6.5 to -3, -3. But through multiplication, I need that 9. That's why we do this approach here. Okay, we do that to say, hey, I need a 9. Now, the difference here is, what is our objective? I'm trying to go from general form to vertex form. That is our purpose here. We want to know the vertex. Is that clear to everyone? Our focus right now is not solve an equation, but get the vertex. So that's why you see this written a little bit differently. Okay, I could have done this before in the past, though, but there we had an equation. Okay, with that said, though, what that allows me to do now is to write that in that factored form, right? The factors of 9 that add to 6 are 3 and 3. Both factors are going to be x minus 3 and x minus 3. Just be careful to see you had that -9 now. And remember, the -9 has to tag along because I put the +9 in. Okay. Well, guess what? I can write this as x minus 3 squared. And what number do I need to combine with the -9? The 3, right? So that's where we'll find that, hey, look at that. I'm able to bring the 3 back in. So you're good with why I wrote it twice. What does that equal? Right, and the whole reason we want 0 is because I didn't change the problem. Does everyone understand that any number plus 0 is itself? Okay. What did I do to these here when I went down? I factored it, right? So if you need to, use the factor by grouping method, but make sure you see here that, hey, -3 times -3 is +9, which we kind of wrote already. And then -3 plus -3 is -6. Now, what we wanted here was the factors to be identical. That's what completing the square does. We force those factors to be the same.
But those aren't the same. You probably did something.
Exactly. If they're not the same, that's not going to help us, right? If they're not the same, there's no point in doing this. That's why completing the square is useful. I'm forcing it to this state. Okay. With that said, though, why is it -6 at the very end? What number did we not want to forget about? Right, but that +3, right? We didn't want to forget about this as we go through the problem because that was the original C term, right? So with that said, though, make sure you see here, we now can identify the vertex. And that 3 -6 has nothing to do with the one we see at the beginning. So please don't, we'll see in a second they have relationships, but it's not exactly connected. Now, are we going to have to do this all the time on our own? Why not? What did I say? Well, yeah, that one was nice, but when is the only time you have to complete the square? On the final. Is everyone clear with that? So use this time to try to get more confident with it, but go back to the fact that, hey, this is us just practicing it right now, okay? Everyone follow that. Now, this one was nice, right? Because A was already 1. All right. But what is this A value again? 3. Now, what you're going to find here, this is where we can be creative on how we write this. Because division allows me to get to 3, but guess what? We could take advantage of factoring right now. So what did I do? This time it's a little bit different than the previous one. I pulled the 3 out. Does everyone see that I isolated the same way though? Now, what's in front of the bracket so that we don't want to lose? 3. So now we have to keep track of the 3 and a negative 17, right? But don't make that negative 17 thirds. Is that clear on everyone? That's just going to make it harder on you in the long run. So don't worry about that right now, okay? With that said, though, make sure you see I was able to isolate those variable terms. But make sure I also note that the 12 is now 4, right? We factored out the 3, so it affected the x squared and that 12x, okay? What do we need to do now? All right, so half of being squared, right? And what do we do with the 4? Right. Now, why are we doing plus 4 minus 4? Does everyone feel okay with that though? This is just a special case, and the reason I want to make you show this is what it's going to look like with the circles. The circle, we're going to have a similar situation where, hey, we want to go from a general form to a kind of a standard form in a sense, so that we can see something important. For us right now, what are we trying to get? What point? But what point are we trying to get to that I put the very bottom? Now, we're trying to get to the vertex. That's what our goal is right now. Okay, so keep that in mind. Now, with that said, though, when you get that plus 4 and everything in there, our focus is going to be to factor the trinomial. That's our whole focus here. So we can go down that next step and say, hey, this is going to be 3 times x plus 2 squared minus the 4, close the bracket, minus the 17. Why is the squared important? Yeah.
Because you have to write it, like you're supposed to write it twice.
Does everyone see that represents 2 factors? What we write is the square though, because it's 2 factors that are exactly the same. If you need to though, again, write it like I did the first one, right? Write out the 2 factors to show yourself, oh, hey, they happen to be the same. So I can go that one more step. Okay, you don't need to do that. Now, the part that makes this one a little bit more involved is there was 2 things outside the bracket, right? I'll deal with that negative 17 in a second, but what do I have to deal with now? The 3, right? So we have to distribute the 3 back in now, right? So what you're finding there is, hey, we pulled out the 3 to have to go multiply it again a little bit later, right? So what this will become is 3 times the part that's squared, okay? But that negative 4 becomes what? So the negative 4 is now negative 12. With that negative 12, though, we can then add that together with negative 17. And we have our standard vertex form. So we can go ahead and, oh, hey, I got my vertex now. For what? Why do I have a negative? You tell me.
Oh, I'm done. I'm done.
What? That's a transformation, right? Because it's the opposite. We do the opposite for those transformations. So like this one here, remember I put it as positive. So we distributed this 3 to both of those.
So I have a question. So for that 3, would that 3 be a stretch?
Yes. Now, did the 3 change from the 3x squared down at the bottom? So does everyone see how, like I wrote back here, that these a's are the same value? That's one of the nice things about going between the forms, right? That leading coefficient didn't change. The leading coefficient that we had with the general form is the same one that we use in vertex form. So that's why you saw that I still put a here. These are the same a value. Now, what does change is I no longer have b and x, right? So I couldn't use the quadratic formula. I cannot use the quadratic formula when I'm in this form. Okay, so understand there's a give and take, like I said. It all depends on what we're trying to do. But I would say with this one, it'd be a little bit nicer to graph now than it was previously. Okay. Talk about this one. All right, so this is where it came from, right? This 4 here was not there either. So why did I put -4 right behind it? What would that give us if we simplify? 0. That's why we need the -4 because of 0. Now, remember the reason we used 4, though, is from this part here. We divided this through this process. Just know that, like, as you saw here, I did the same thing with the 9. Right? That -9 needed to follow right after it. Okay. Now, I also highlighted here only 3 terms, though. We need the +4 for the factoring purposes. The -4 is there for balance of truthfulness, right? That really all I did was took a number and added 0 to it. So technically, it's still the same number. Okay. Now, the one thing again, I'll say the purpose behind this is to get it from the general form to vertex. That's the purpose. Okay. Anything else I clear up? What other fun stuff do I have? Let's do another fun. All right, put up your notes. Please do not copy this down. So understand that our focus right now is quadratic functions. Yeah, don't write this down. Right, but I'm putting stuff just kind of hey, this represents any quadratic function. The first form, as you see here, the ax squared plus bx plus c is what we call general form. We like it because, hey, a times c, I can use that for trying to factor. If I can't factor, I have something like the quadratic formula where I identify a, b, and c and plug it in. The next step you see here is the standard form. We like this standard form, or also known as vertex form, because it helps us with graphing. I can go in and get the transformation, stretch, shrink, reflection, and get a graph quickly. Now, as you saw, hopefully with those first two, you can get the x-intercepts pretty nicely too. You just have to remember the square root property, okay? But what you're going to find oftentimes when we deal with stuff like quadratic functions, we need to find the vertex, right? We need to find the vertex. So what we want to do is find a way to rewrite this general form into that standard form, which is why we did the previous 2 problems. That I took something in general form and rewrote it in vertex. Those are the same function, just in 2 different forms. Okay. With that said, though, we can do that with any quadratic. Now, hopefully you're thinking back that I've already been through this, right? We've dealt with this because we did it for solving quadratic equations, right? When I did all that work, we end up getting the quadratic formula. Now, what I want you to see here, it's going to look a little bit different because we're doing it to the expression, not an equation right now. So as we saw in the previous one, we can do stuff like factoring. So, hey, I want it to be 1x squared, so I need to factor out the a. Oops. So that we can get x squared to just be 1 in front of it. Now, what did I insert to this expression, right? Make sure you see here, I put the brackets there to say my focus right now is on those variable terms. Now, also make sure you see, we have an a that we don't want to forget about, as well as the plus c. Those still are important parts of what we're working with, right? Those are not getting forgotten. I just kind of tucked them outside for now. With that said, completing the square says take half of that b value. So I need to do b over a divided by 2, and then I'm going to square that. Now, right now, we don't know what b over a is, but make sure you look back. We actually knew what it was. But make sure you see here, we can use like, hey, division by a number is multiplying by its reciprocal. So this would give us b over 2a. And then when you square it, the power rule says to square everything. So b squared all over 2 squared and a squared. Now, with that said, though, that's the piece that we need to factor this. So we're going to put b squared over 4a squared here, but what do I need to put to make sure I'm not changing this expression? I need to subtract it, right? We don't want to change the expression. We're just using it for a purpose. The purpose of using that is to factor. Is that clear to everyone? Now, with that said, we can factor now. Just make sure you remember, though, as we go back to those other problems, that part where we divided by 2, that's what we use in the factors. So we don't have to kind of go through this and guess right now. We already wrote it out. This is going to become a times x plus b over 2a x. I'm factoring right now. So x plus b over 2a, the whole thing squared. And then I'm going to have that minus b squared over 4a squared. And don't forget to close and add your c here. Now, what do we have to do with the a, though? Because we're not done yet. We've got to simplify a little bit. Yeah, we want to deal with these brackets, right? So we're going to have to take this a value and distribute in here. Okay. Now, make sure you see here, as we saw before, the first a needs to be right in front of the parentheses. That's a good sign. That's the form that we were looking for. When I do a times this here, I already had 2 a's in the denominator. So I'm just going to have 1a in the denominator now. So that'll just be minus b squared over 2a. And then over here, we'll have plus c. Now, at that point, we have what we need. Okay. All we could do at that point then is add those two things at the end, but there you need a common denominator. But this is something that's going to be helpful for us as far as what we're looking for. We're not working right now. Not 4. All right. Now, make sure you see here, though, that this is what we would call standard form or the vertex form. Doesn't necessarily look nice, right? There are some things in here that we've seen kind of before, like as far as hopefully you're seeing some connections to the quadratic formula, but there's some weird stuff going on that we're going to have to talk about as well, right? That's a little bit different. Now, the one thing we can work with, though, is this statement here. What does this represent when we talk about the vertex? So remember, my first thing I had up here was that this is equivalent to a times x minus h squared plus k. So what does this represent here? H. So that means I can conclude then that h is always going to be negative b over 2a. Now, what is this going to equal then? Do we really need to copy that down, though? That probably wouldn't be fun to work with, right? So we're just going to leave that one alone. Yo, I totally screwed up. I knew it looked wrong. What am I supposed to have out here? But what's that? A 4. I knew something didn't look right, yo. I'm sorry. I took the a and a 2. I don't know why I messed with that. So make sure you see here. This times this, that's why there's only 1a left. I should have never touched the 4. Does everyone follow that? I'm sorry. But hopefully you see now that looks more like the quadratic formula. You know, the b squared minus 4ac. Now, we're not in the equation, so that's why it does look different right now. But what I want us to take from this would be the piece that, if you want to kind of take a picture of and make sure you have highlighted, is that last piece there, that h equals negative b over 2a. And I'll make sure we practice this a little bit more tomorrow. But what we can do then is come over here and confirm that. If h equals negative b over 2a, I can take this problem that we just worked with and plug in the value, see what happens. What's my b value for this problem we worked with? What's the b value here, y'all?
Oh.
It's the 12, right? And then 2 times 3, because we already identified the 3. Well, what's 12 divided by 2 times 3? It's 6, right? 12 divided by 6 is 2, but make sure you see it's negative 2. Should we be surprised to see a negative 2 right now? It's already in the vertex. It is kind of cool. And now what you're going to find is we have a quick way to handle this that we're going to look at moving forward here soon. That'll allow us to get to that other piece. We haven't got there yet. We're going to get there, but I want to show you that once we get that, this makes it kind of nice to work with because what number did I get? That's all that matters. -29. Now, what you found, hopefully see here, just plug -2 in and you're going to get what you need. Just go over here and say x equals -2 and plug it in here. Don't worry about that. I'm going to show it to you next week. It's called synthetic division. But I wanted to show it here, though, as an example of you can quickly get from the -2 to the -29 by plugging it in. So I cleared everyone? It was awesome, wasn't it? I like it. It's art. You call my script, my art scribble scratch. Now I'm offended. What were you saying, though?
I was like, I